Hello, this is Hamid Microsoft Group. Today we are going to work on this problem. You can see water comes into this pot and see how it's gonna react. First of all, please subscribe our channel, like our video, turn on the notification to let us be your guest at your home and learn many ansys points together. To start it, we will go to ansys workbench. We drag and drop fluent like this. I have already done it. Let me close this one. Then you will right click on the geometry and we'll click on edit geometry in design modeler. I have already done it, and right here we have design modeler. To start it, we will change the units to millimeters, and then we'll click on Z to have a normal view to XY plane. Then we'll click on sketch and go to sketching. Let me zoom in a little bit. We will draw a line like this, and we will insert a dimension of 50 millimeters. After that, we will continue the model, go to draw line, and like this we will have our model. These are the lines. It will be like this. Let me insert other dimensions. We will choose vertical and 2 points. The next one is this and this. We want V2 to be 120 and also H4 as 10 and V3 as 25, like this. We will keep going the rest like this. We will do the same in the left side. Something almost like the half we have in the right. Then we'll go to constraints and we'll choose equal length. We will make all of the lines equal, and also this one, as you can see right here. Let me clean this one and do it once again. Okay, this is our sketch, and to continue we'll go to concept. We'll choose surface from a sketch because we need a surface to have analysis on it. We will choose all of them by this box and apply. Once again, single click, and then we will click on generate. You have a surface from the sketch we drew like this, and after clicking on this part right here, you can change the mode to fluid. Right now the software will recognize this place as our volume of control, and it is made of fluid. It is time to close ansys design modeler Now it is time for mesh. Right click on it, edit, and we will wait until it is loaded. It takes a little bit time. It's still loading. As far as it's not completed, do not do anything, just wait. We will click on generate to see the default mesh for our model. It is like this. Let me click on Z to see it exactly. As you can see, the meshing is not great, it's not appropriate, so we have to change the element size. We will decrease it. For example, we will insert 0.005 because the unit is in meter. We will click on generate to see what's gonna happen. It is like this. It still needs to be smaller. We will insert 0.001. Once again, generate. Let this loading be completed. This is a better mesh, I think. We will see the changes better in this one. Now we will change the selection mode to edge, and we'll click on all of them to recognize the walls. We will press on N on our keyboard to name these lines as wall. These are boundaries, and then we will click on the inlet. We can also right click on it and create name selection. Both of them are the same. Pressing N or right clicking on it and name selection. As you can see, like this. Let me click on generate and then click on name selection. It is wall. It is completely selected. Always check this one. And this is inlet, because if you choose repetitive lines, the software will come to an error. It is okay right now. The meshing is great and the name selections are complete. So let's close this one and right click on it to update our meshing. Just wait a little until this one is green. Just wait. Now it's okay. You can see the green tick right here. We will go to setup, right click on it and edit. Once again, we have to wait until it is loaded. You will see this table like this. We always click on double precision to have better answers, and do not increase more than 2. 2 is okay, because if you increase this one so much, it will ruin your case, your system, your PC. So do not never ever put more than 2 on this table and click on start. You could see that 3D was locked for us because the software recognizes that the model is a 2D one, so it was locked. We will wait until this one is loaded. Right here we'll click on OK. Let me wait a little bit. We'll click on OK, and then you can see the meshing right here and the inlet. As you can see, we'll choose transient because our analysis is based on time. It is changing during the time. We will click on gravity and we will insert minus 9.81. It is our acceleration, as you can see. And right here we will call water to see it, materials, click on the plus, right click on it and new. Right here you can use a fluent database. You click on it, you scroll down to see water liquid right here, and then you can see all the constants for water. We will click on copy and close it. Then we will click on change and create. After doing it, besides the default materials of ansys fluent, I mean air and aluminum, you can see water liquid because we called it from database of ansys fluent. We have water right here. We'll go to models because you know that our model is a multi-phase one. It is at first full of air as a fluid, then the water comes in, so there are two phases. We will click on multi-phase. We will click on volume of fluid for our problem. Do not forget to click on this one, implicit body force. It means that the reaction between the gas, I mean air, and the liquid, it is water, is completely estimated in our analysis. So do not forget to click on this one and then apply. As soon as you click on apply, these tabs are enabled. You will click on phases once again. The primary phase, as you know, is water. This is our primary one, and we will change the name to recognize it during our analysis. And our secondary phase is air. We will change the name and we'll choose air. Once again, primary phase water, and secondary phase is air and air. We will click on apply. The next step is to go to phase interactions. As you can see, you know that water always have surface tension, so we change this one to constant, and we will insert 0.0725. This is the surface tension of water. We will click on this one either for force modeling because we want it to be inserted in our analysis. We'll click on apply and close this tab. After that, we will go to viscose because we don't want any temperature or any heat analysis. We just go to viscose to choose our modeling. As you know, the problem is not that fast and it's internal, so we'll click on K epsilon. It is good as a model for us. Do not never change these numbers. These are okay. These are calculated after many experiences by the ansys producers. We will click on realizable because a little bit our analysis is complicated. We want it to be more powerful. We will click on OK. The next step is to go for other options we have to specify. For example, let's go for boundary condition. We double click on it. You can see right here, and if you click on this minus, you have different places like this. and let's insert the inlet velocity. As you know, when you name a boundary as inlet, it automatically assumes this as inlet velocity, and right here by inserting, for example, 0.25, we will specify the velocity we want as inlet. We click on it, apply. Right now the velocity shown here is 0.025. As a next step, we have walls. Walls are not stationary, they are fixed, and this is the default. That's okay, there is nothing to change right here. And about the inlet, let me tell you something, perhaps it's good. If I change this one mixture to air right here, you will have a volume fraction. As you know, in the inlet you don't have any air, so the volume fraction as a default 0 is okay. And make sure that this one is 0. This is exactly according to the condition of our problem. That's okay. The boundaries are okay right now, and the next step is to specify the in the method what method you want to solve the equations. Piezo is the greatest one for our problem because it is great for transient analysis, exactly like this. The other options which are as the default are okay. Press 2 second order up pin, and all the other are okay. There is no need to change them. As you know, in ansys fluent, the downer you want, the more complicated algorithm you have, and right here it's not that complicated. If we solve it and face problems, we will come here to change these factors. At first I will change the controls factors, and if it didn't work, you will go to method and we'll change these options. The next one is monitors. We'll go to residual. It will determine the accuracy of the solution. We will increase it up to 0.001. We will copy this one, Control C and Control V for all of them. We will insert this number. Do not increase it more than this one. It's okay, because if you increase it so much, your calculation will be so high, and it will take a lot of time to solve them. This accuracy is okay. For example, continuity equation must be solved until having this accuracy: x velocity, y velocity, k, and epsilon. All of them, these are the factors we have in this model viscose right here. We need all of them. And the next one is initialization. It must be done. So at first we will insert 0 as turbulent kinetic energy or turbulent dissipation rate. All of them must be 0, and actually air volume fraction is not 0, because at first you have air in your pot, so the air volume fraction is 1. As you know, volume fraction is the volume of a special material over the whole volume. So the whole volume is air, and the whole volume is like this, so it will be 1 as the first step. You know that initialization is the first step of the calculation. So at the first step, all of these factors are 0. There is no velocity, there is no kinetic energy, because it's completely fixed. and it is full of air. If it's full of air, we will insert 1 as air volume fraction, and then we will click on initialize. Now our analysis is initialized, and as the next part we will go to solution animation. We will double click on it because we want an animation about the process of the problem. There are different type of storage right here. In memory, if you click on it sorry, you will sorry, if you click on in memory, the video will be just in the memory and it will be deleted after closing the software. So we will not choose this one. We will choose HSF file. That's a good type for us. It is recorded completely. We will click on new object and we will insert contours. We want our animation to be as a contour, so we will click on this one, contours of phases we want to have, and then volume fraction as a default, and the phase we want to see is water. All of them are okay right now, and we will click on save display, and the next part we will click on contour 1 and preview. We want to see the preview of our problem. You can see right here there is a change here after clicking on it, and we will click on OK. The next step is going for calculation activities. We will so we'll click on run calculation, and right here there are some options which are so important. The time step size, as you know, the Fluent will start solving the equations, and step by step it takes a picture, and by putting them all together we will have a new animation. We will insert 0.01 as the steps, so every 0.01 second we will have a picture. They will put them together to have an animation, and the number of time steps is, for example, I think 1500 enough. I think if you think better about this one, it means that we will have 15 seconds of the calculation, 15 seconds of the animation right here. By clicking on calculate, the process is started. Let me show you some factors right here and then see what's gonna happen. The process is getting done. After some moments you can see that the red part of the pot will develop, come down, and this is exactly the way it's gonna water react in this problem. It takes a little bit time. Actually, I didn't let it complete up to the last time step. I pause it, but let's see what has happened till now. We will go to animations, playback. Right here you have your animation. If I click on this one, you can see that how the water came down with a velocity of 0.25. Once again, this is how it is done. And as you can see, these are the time steps, and you can see that after putting 780 time steps together, you can make this animation like this. And I really suggest you to change the shape, change the velocity inlet, change the change the condition of the problem, and do it yourself. Try to face different challenges, go for them, ask for them. You are allowed to leave any comments you want and ask any question you have. I hope I can help you. Please do not forget to subscribe our channel, like our video, and introduce our page to your friends to learn ansys, SolidWorks, and many other mechanical engineers to softwares together. Thanks for staying with us, and have a great time. Goodbye.